Objective 7.1 is the introduction of circles. So it introduces just a few manageable concepts about circles. And the first one is, what if you see a circle or the equation of a circle written in its standard form, where everything is presented as a perfect square like this? Well, you can identify the center simply by using the rules we've used throughout the entire unit, and that is anything that's directly attached to the variable is thought of as opposite. So the center of this circle would be -3. The x-coordinate would be -3. Now the y-coordinate, nothing is happening to the y-coordinate, so -3, 0. So the center is -3, 0. So if I marked that, I think -3, 0 would be about right here. And then the radius would be the square root of that number, so square root 80. Now, your teacher might have you do one of maybe several things. The radius of square root 80, well, it's almost the square root of 81, and the square root of 81 is 9, so we know this is just a tiny bit less than 9. Now, your teacher might actually want to know the value, so you would take 80 and find the square root of it, and we've got 8.94 is a more precise, it's not exact, but 8.94. Now, the other thing your teacher might want is, well, what is it in if you simplified this radical? And that would be breaking the 80 down to 10 times 8. We know 8 is actually 3 2s, and 10 is a 2 and a 5. So what we have is we actually have two pairs of 2s, which would be 4, so that would be 4 square root 5. So there's quite a few different ways of identifying what the radius is. But if we have to draw it, I think probably what would be best is let's go with this almost 9. So if this was -3, well, if I went 9 units from -3, I'd be at about 6. If this was -3 again, and I went 9 units that way, I'd be at about -12. Now, the y-axis, I'm at 0, so 9 is simply 9. And then down here, -9 would be about -9. Now, this would be my best attempt at drawing a circle out of those points. That's not bad. Kind of got crazy over here, but that's it. That's the sketch of this circle. Now, the next thing, example number 2. Write the equation of the circle if we knew certain things. The center of the circle began at 0, 0, but then the circle was shifted. It was shifted 7 units to the left. Well, that would affect the x-coordinate by subtracting 7. And then it was shifted 2 units up. That would affect the y-coordinate by adding 2. Now, what this gets us to is what we call C prime, the circle in its new position. 0 minus 7 is -7, and 0 plus 2 is +2. That just tells us that's the new center. So what does our equation have to look like to achieve these coordinates? Well, in order for having an x value of -7, it has to be x plus 7 squared. In order to have a y-coordinate of +2, it has to be y minus 2 squared. Now I have to have it equal something, and this is always r squared. So if the radius is 2 square root 5, then I simply need to square that. Now, 2 squared is 4, and then the square root of 5, when it's squared, is 5. So the answer is 20. So that's 20 right there. And that's the equation of the circle. Example number 3 revolves around the idea of how do you test a certain point to see whether that point is inside, outside, or on a certain circle. Well, you just plug it in and see what happens. So we've got this example right here. Is this particular point inside, outside, or on this circle? So we're just going to plug in -4 for x. So that would be -4 plus 2 squared. And then we're going to do the same thing. We're going to plug in a 6 where we see the y. 6 minus 3 squared. But instead of putting an equal sign, I'm just going to put a box, because we really don't know if it does equal 25 or not. Now we just start evaluating. -4 plus 2 is a -2, and then when you square it, you get 4. 6 minus 3 is 3, but when you square it, you get 9. And what is that when you compare it to 25? 13. 13 is less than 25. So that means -4, 6 is inside this circle. So I really don't have equal signs here. I'm replacing the equal signs with the box. Now, if it really did, if I got 25 over here on the left and that was 25 right on the right, and an equal sign did go in the box, then that would mean that this particular point is right on the edge of that circle. Now, example number 4. Completing the square and write the trinomial as a perfect square. We're going to be using this concept a lot throughout the entire unit, because when you write the equation of a circle in its general form, we need to have perfect squares. So the way you create a perfect square, x squared minus 12x is not a perfect square. But the way you do it is you divide this number by 2, so -12 divided by 2, -6, but then you square that number to put it right there. And what you do to one side, you have to do to the other. Now, I guarantee you, you've now created a perfect square. X squared minus 12x plus 36 is x minus 6 quantity squared. And then on this side, 8 plus 36 is 44. And for as far as objective 1 is concerned, that's all we want you to do, is create a perfect square. So it's always the process of take this number, divide it by 2, and then square that number.